In this lesson, we're going to continue finding angles, but we're going to take it a step further and provide justifications for each step, which is really just a fancy way for saying we're giving the reasons for each step. And this is actually what a proof looks like. It gives the step number, what you're saying is happening, and why you know that. So it's going to give us some information here. It says that lines AD and EG are parallel. So this line and this line are parallel, which obviously they look like it. Also tells us that segment BH and FC FC are perpendicular, so there's 90 here, here, and then this is 180 on that side. And then measure of ABH is 146 degrees, they give us in the diagram. We're finding the measure of angle EFH. EFH would be right here. So we start with what we know. Right here, this angle forms a linear pair with the smaller angle here, which I'm going to call HBC. So measure of HBC. All I have to do is take 180 minus 146, which is 34 degrees. And the reasoning I know that is because these two angles are a linear pair. So I come to my list and I see linear pair, or could be a triple if there's 3 angles on a line. Hit try, and it should now give you the new angle in green. Okay, so then what that allows me to know is that here is a triangle with a right angle. I know triangles have 180 degrees, so 180 minus 90, which is 90, 90 minus the 34 would make this angle right here 56. I would have to call it either angle HCB or BCH. And the reason I know that is because 3 angles inside a triangle add up to make 180. So sum of the angles in the triangle is always 186. Okay, and then I've got, let's see, I'm finding this one. So I've got a couple different ways here. If I know these lines are parallel and this is my transversal, I see alternate interior angles here and here. So I'm going to say that angle GFC is also 56 degrees because they're alternate interior angles. So that puts that there. Now it's easy for me to see that I'm finding this obtuse angle here, EFH, and this is a linear pair. So I would take 180 minus 56, and that should be 124. So angle EFH is 124 degrees because they are, again, a linear pair. Now that wasn't the only way I could have done it. I could have also noticed that this angle here and this angle are consecutive or same side interior, and that they are supplementary because these two angles add to make 180. So that would have actually combined this step here. But sometimes I just go with what makes more sense in my brain instead of the shortest amount of steps. Okay, so hit submit. Tells us we're right. You can go through the steps again if you want. Got 2 more of these to do just to practice. All right, it says in the diagram below, AC, so this line is perpendicular with CB. You can see they make a right angle here. And also AB is perpendicular to CD. They make a right angle here. Measure of angle A is 30 degrees. Find the measure of DCB. So we want just this little part here. And then starting with this, I would then think a couple different ways. Let's see, if we were to find this angle here, we could then find that angle, so that would probably be the fastest. So in this triangle here, ADC is 180 degrees. 180 minus 90 would be 90. 90 minus 30 would be 60. So angle ACD would be 60 degrees because of the sum of the angles in a triangle. Well, if this adds up to make 90, I know that this has to be 30 because 30 plus 60 makes 90. So I'm going to say the measure of BCD or DCB is 30. And then there's got to be some kind of this angle. Do you remember angle addition postulate is 2 angles added together? So if I would have had a 30 and a 60, adding them to make 90 would have been that. I actually want to choose the angle subtraction because I knew the total angle was 90. I took 90 minus 60 to be left with 30. So angle subtraction allows you to find part of the angle versus angle addition adds 2 smaller angles to make the final angle. And then it says you're done, press submit. right, one more. Says that AD is congruent to AE. AD and AE. What that tells me is that this is an isosceles triangle where these two angles here and here will be congruent. We've got BA parallel to CE, CB parallel to AD, and they give us an angle, and we're trying to find the measure of BCD. So this little one right here. So let's start with this isosceles triangle. I know 180 degrees minus 54 gives me 126 for these two. Then I can evenly divide that by 2 to say that these angles are both 63. So let me start here. I'm going to have to call this angle ADE, 63 degrees. And the reason I knew that was because they're base angles of an isosceles triangle. Okay, so then I could find this angle here, because this is a linear pair. So 180 minus 63 is 117. So measure C, D, A. And they're a linear pair. Okay, and my job is to find B, C, D, this angle. So they told me this line and this line are parallel. This and this, if I extend this transversal, are same side or consecutive interior angles. They should be supplementary. So if I take 180 minus 117, I get 63 degrees again. I could have also looked at that, since this line AD is parallel to BC, this angle here would be the same as this one. So I could also use a corresponding angles, but I'm going to say that measure, I could even just call it C, is, what did I say, 63 degrees. My reasoning is because they are same side interior. And you are done. Let's see what they put. They only did it in 2 steps. So they did the 63, and then see, you've got corresponding angles here and here. So multiple ways to get the same answer.